So far we've looked at obviously testing claims about averages. We looked at one sample tests, two sample tests. Now what we're going to do is talk about what do we do when we have three or more samples to consider. So analysis of variance is a method for testing the equality of three or more population means, and that's done by analyzing sample variances. So for our purposes, StatCrunch is still going to be doing all the heavy lifting with the computations, but just the connection for where that language comes from. The analysis of variances, that what's happening in the background, is the sample variances for each of the data sets will be analyzed to come to some conclusions. So essentially what we're doing in a problem like this, if we're testing a claim about means, we'd be testing the null hypothesis that mu1 is equal to mu2 is equal to mu3. So again, we're always going to have at least three data sets, because if we had less than three, we already have some methods established for that. Or we might have more than that. So we could have a fourth, fifth, sixth. So that list is going to go on for however many data sets we have. Versus the alternative hypothesis that at least one mean is different. So the null hypothesis that they're all equal, the alternative that at least one is different. So why do we need a new test? The reason is that our current methods would require us to use a two-sample test. In a first test, we'd have to test the claim that mu1 is equal to mu2. In a second test, we would test a claim that mu2 is equal to mu3. And then in a third test, we would test a claim that mu3 is equal to mu1. So if we have three samples to consider, we would need at least three tests to investigate all of those claims. And then if we had 4 samples, 5 samples, the number of tests would just continue to increase. So keep in mind that with each test, we compound our potential error. So again, each test has the probability for a type 1 error, which is that value alpha, the probability of a type 2 error, which is beta, which again, keep in mind we never know if that error occurs. We never know for certain if we come to the wrong conclusion. So with each test, if we introduce more and more error, what we're doing is leading ourselves to less accurate results. So this analysis of variance approach is going to allow us to reach the same conclusion about the equality of these different means. But since we limit it to just a single hypothesis, or a single pair of hypotheses that we have to test, we're going to get to the same results with fewer tests and less error. So all of inferential statistics is trying to draw conclusions about our populations based off sample data. We always know there's going to be error. So we want to do everything that we can to minimize the amount of error that occurs, and this will be another technique to do that. When we have multiple samples to consider, this gives us a way with a single test to draw some conclusions about all of those different populations at once.